Hello class, today we're going to talk about section 2.8, which covers literal equations and dimensional analysis. By the end of today's lesson, you will be able to rearrange an equation for a specific variable and convert quantities and measurements from one unit to another. Literal equations are equations with more than one variable. It's important for us in algebra to be able to solve for any of these variables within the equation. The other concept that we're going to be learning today is dimensional analysis, which is the process of converting units and measurements from one quantity to another. So for example, going from feet to inches or from feet to centimeters. So we're trying to change those units on the values. First, we're going to talk about literal equations. So here you see we have the equation 15 equals 3n plus 6p. This first case on the left, I'm going to go ahead and solve for n. So I want to get n by itself. First, that means I'm going to need to get rid of the 6p. So I'm going to subtract 6p from both sides. Now we know from previous lessons that I can't combine numbers and numbers with variables, so I'm simply going to write 15 minus 6p is equal to 3n. The next thing I'm going to need to do to get n by itself is get rid of that multiplication by 3. In order to do that, I'm going to divide by 3. On the other side of the equation, I need to divide each piece by 3. So I'm going to have 15 divided by 3, which gives me 5, and negative 6p divided by 3, which gives me negative 2p. And that is equal to n. So I have solved this equation to get the variable n by itself. Over here on this other side, now it's asking us to solve for p. So instead of getting rid of the 6p, we're going to start by subtracting the 3n, because we want p to be on its own side now. Again, we can't combine 15 and 3n, so we have 15 minus 3n is equal to 6p. Again, we want p to be completely isolated, so we're going to go ahead and divide by 6 on each of the quantities. When I do 15 divided by 6, I end up with 2.5, or 2.5. Negative 3n divided by 6 gives me negative half n is equal to p. So we took the same starting equation and we were able to solve for the two variables involved in this literal equation. Go ahead and try this one on your own, solving for variable g. So first we subtract 4y. We're going to go ahead and divide everything by 8 then, which gives you 37 over 8 minus 1/2 y. Or if you did it in decimal version, 4.625 minus 0.5 y. Another thing that we might have to do is solve for a variable that's listed more than once. So notice here, x is listed on both the left side and the right side of this equation. The first thing you're going to want to do is get all those variables to one side. So I'm going to go ahead and I'm going to subtract xz over to the left side. So now I have 3x minus 2y minus xz is equal to 5. Since I'm trying to isolate x, I want to get rid of this y that's on the side. So I'm going to go ahead and add 2y to both sides of this equation, giving me 3x minus xz is equal to 5 plus 2y. Now, in order to get x by itself, we need to pull x out of each of these factors. This is something that is going to look a little bit opposite of the distributive property. So with the distributive property, just as a side note, remember we did 7. For example, 7 would distribute to the x and the 2 and give us 7x plus 14. Our goal now is to start here and go backwards. So we're going to go ahead and we're going to pull x out of both equations. So if I pull x out of 3x, I've got a 3 left over. And if I pull x out of xz, I've got a z left over. So all I did in that step was pull x out of both of those pieces so that I could try and get x by itself. Now, if you notice, I've got x times this value, because that's what the distributive property would tell us to do. In order to undo multiplication, we would divide by the values in parentheses. So we're dividing by the values in parentheses. Obviously, I don't expect you to know how to divide those variables out, so we would leave that as a fraction, which has 5 over 2y, or excuse me, 5 plus 2y over 3 minus z. So again, we start by getting all of the variable that we want to solve for on one side. In this case, both x's on the left side. Get all other variables being added or subtracted to the other side. So add 2y. Pull our variable out from the quantities, so out of 3x and out of xz, leaving us 3 minus z. And then we divide by that parentheses values, leaving us with just a fraction as an answer. Go ahead and try this one on your own, solving for a. So we're going to start by subtracting a to get the a's on the same side. And then we're going to pull the a out, which gives us q minus 8, leaving us with an answer of 23 over q minus 8. One final example on this, we have our circumference equation. Circumference is equal to 2 pi r. It wants us to solve for the radius. So we're going to divide by 2 pi, giving us the equation r is equal to c divided by 2 pi. This is one of the reasons we rearrange this equation so that to answer the question, it's much easier. So go ahead and plug in that value for c and solve for r. You should have gotten an answer of 12 centimeters. The other concept in today's lesson is going to be dimensional analysis. This is the conversion chart that we will be using to help convert our units. You can go ahead and take a screenshot of this. I will also be providing you with a paper version when you get to class. So we're going to start off today by converting 6 miles into kilometers. So you're going to go ahead and refer to that chart to figure out how we can convert 6 miles into kilometers. You'll notice that there's two options. One conversion factor that says 1 mile is equal to 1.609 kilometers. And on the other side of the chart, you'll notice a conversion factor that says 1 kilometer is equal to 0.621 miles. I'm going to go ahead and show both examples, but you only need to do one. So for our first option, we're going to say we have 6 miles, and I'm going to trade that in 1 mile at a time. So I'm going to say 1 mile is equal to 1.609 kilometers. We are done with our conversion there because the units of miles and miles cancel out, giving us kilometers to finish. So I'm going to go ahead and do 6 times 1.09, which gives me 9.65 after rounding, over 1, and our final answer is 9.605 kilometers. With our second option, again, we're going to start with our 6 miles, and I'm going to plug in this time we're going to use that second conversion factor, and we're going to plug in 0.621 miles is equal to 1 kilometer. Again, we're done after this conversion because our miles cancel each other out. Multiplying the top, 6 times 1 gives me 6, and on the bottom I end up with 0.621. After I divide that out, I'm going to get an answer after rounding of 9.66 kilometers. So notice the answers are very similar, but they're off by 1/100th of a decimal place. When I'm looking at your homework or looking at the test, I will have all of the possible conversions on there, so it doesn't matter which one you pick to do. You will have both options. Go ahead and try this one on your own. Again, this is one of the two options using the 1 ounce is equal to 28.35 grams. If you use the other conversion factor, that is completely okay. Looking at this one now, we've got the average teenager spends $1,742 per year on clothing or fashion-related items. How much is this per week? A new key thing that we have in this problem is the word per. Prior to this problem, we have only ever been plugging information into the top portion of this box. Now that we have the word per, we're going to have something on top and on bottom. The quantity in front of per goes up top, so $1,742. The quantity after per, which is 1 year, goes on the bottom. So when you have two units, in this case dollars and years, that's why we have two portions set up. Now we're trying to change how much is this per week. We're not trying to convert dollar amounts into anything, but we are trying to get years into weeks. If you look at that top of the chart, I tell you that in 1 year, there are 52 weeks. Notice how, again, my units are lined up diagonally from one another so that they can cancel out. Now, we have dollars per week, which is what we want for our final answer. So I'm going to go ahead and multiply the top. 1,742 times 1 is 1,742. And on the bottom, 1 times 52 is 52. Then I'm going to go ahead and divide those out, which gives me a final answer of 33.5. But in order to make it proper units, we're going to add that 0 so that it's $33.50 per week. So notice how I included both of my labels, dollars and weeks, as part of my final answer. Go ahead and try this one on your own, remembering that miles to miles is not changing, but hours to minutes is. So we convert 1 hour is equal to 60 minutes. So we plug in that information, cross out the hour unit, multiply the top and the bottom, and then we go ahead and divide, and we get 12.67 miles per minute. This final problem, we're going to convert the unit both above and below that line. So we are going to start with 176 feet per 1 second. Our goal is to change feet into miles and seconds into hour. You can read either here in the problem or on the top of that chart that 1 mile is equal to 5,280 feet. So I'm going to plug that in first and say 5,280 feet, and I'm going to get out 1 mile. So what I turned in and what I got out. Again, those units are going to go ahead and cancel out. We're not done yet though, because I want to turn my seconds into hours. So I'm going to go ahead and look at the top of that chart, and it tells me that there are 3,600 seconds in 1 hour. So even though there's a step in the middle, we can still cancel out seconds and seconds because one is on top and one is on the bottom. So now I'm going to go ahead and multiply my values up top. 176 times 1 times 3,600, which is going to give me 633,600. And on the bottom, when I multiply 1 times 5,280 times 1, I get 5,280. I'm going to go ahead and divide those values, and I end up with a final answer of 120 miles per hour. Again, we have that miles unit and the hour unit as part of our answer. Go ahead and try this one on your own. So we go from feet to inches, which is something you should just know that wasn't on your chart. Then we've got inches to centimeters, and then we're going to go from hours to seconds. Multiplying all those values up top, and then multiplying all the values on bottom, dividing to get our final answer of 7.62 centimeters per second. If you have questions about this or anything else from the lesson, please let me know when you get to class.